Sarah has 20 days of customer counts scribbled in a notebook: 142, 155, 138. On their own, they mean nothing. Today, we turn that wall of numbers into a tool that tells her exactly when to staff up. Quick refresh on Sarah's Corner Cafe. Today, we're zooming in on one number: customer count. On an average day, 150 people walk through the door, but average hides a lot. Some days are packed, some days are quiet. Let's find the pattern. Sarah wants to know how many days had different customer counts so she can plan staffing properly. Here's her raw notebook data: 20 days, 20 numbers, scattered in no particular order. Staring at this list tells her almost nothing. She needs a way to organize it so the patterns actually jump out. A frequency table is just a simple structure that counts how often each value shows up. Take cake slices sold over 1 week: 2, 3, 2, 4, 3, 2, 3. Only 3 unique values, so we can tally them by hand. The 3 columns are always the same: the value, a tally mark for every time it appears, and the frequency, the total count. 20 numbers don't tally cleanly one by one. Almost every value is different. So instead, we group them into equal sized ranges called classes: 130 to 139, 140 to 149, and so on. Now the pattern jumps right out. Most days, 7 out of 20 land in the 150 to 159 range, right around the dashboard average. The busiest day hit 172. The slowest hit 130. Suddenly, 20 scattered numbers tell a clear story. Relative frequency just turns raw counts into percentages of the total. Take the busiest class: 150 to 159 customers, 7 days out of 20. 7 divided by 20 is 0.35 or 35%. That's the single most common range for Sarah's Cafe. Over a third of all days land there. Percentages are easier to compare and communicate than raw counts, especially once your dataset gets bigger. Cumulative frequency is just a running total. Add each class's count to everything before it. By the time we reach 150 to 159, we've accumulated 16 days. 3 plus 6 plus 7. That answers a very practical question for Sarah. 16 out of 20 days, 80%, had 159 or fewer customers. Only the top 20% of days ever crack 160. Here's the number one beginner mistake: overlapping class boundaries. If Sarah writes her classes as 130 to 140, then 140 to 150, then 150 to 160, where does a day with exactly 140 customers go? It technically fits in 2 classes at once. The fix: 130 to 139, 140 to 149, 150 to 159. Every value has exactly one home. And here's your safety check: your frequency column should always add up to your total sample size. Here's how to remember the whole process: the 4-column climb. Tally, mark every time a value appears. Frequency, count up those tally marks. Relative, turn the counts into a percentage of the total. Cumulative, add a running total as you climb through the classes. Tally, frequency, relative, cumulative. Every frequency table you'll ever build follows that same climb. Daily revenue has even more unique values than customer count, so grouping isn't optional here, it's essential. To choose your class width, start with roughly the square root of your sample size. Square root of 20 is about 4.5, so aim for 5 classes. Divide your range by that number. $320 divided by 5 is 64. Then round up to a clean, readable number, in this case $100 classes. That gives Sarah a clean revenue table in just 4 rows. Here's the payoff: 35% of days, the single biggest slice, fall in the 150 to 159 customer range, confirming the dashboard's 150 customer average is a realistic baseline, not a fluke. On slow days, Sarah can trim staffing. On typical days, her standard 4-person crew is exactly right. And on the rare peak day pushing past 170, she knows to keep a call-in staffer on speed dial. Today you learned how to build a frequency table using the tally, frequency, relative, and cumulative columns. How to group data into non-overlapping classes when values are too spread out. And how to choose a sensible class width using the square root rule. Quick check. A frequency table's 50 to 59 class has a frequency of 7 out of 30 total days. What is the relative frequency of that class? A. 7%. B. 23.3%. C. 30%. D. 43%. Pause the video and calculate before the answer. The answer is B. 23.3%. Relative frequency equals frequency divided by total. 7 divided by 30 is 0.233 or 23.3%. A is wrong. 7% would mean 7 out of 100, not 7 out of 30. C is wrong. 30% would mean 9 days, not 7. D is wrong. 43% would mean roughly 13 days, way more than the 7 we were given. Sarah's frequency table works, but numbers on a table are useful, and a picture is faster. Her staff can't glance at rows of numbers between orders. That's where we go next, turning this exact table into a chart anyone can read in 2 seconds.
Like, subscribe, and share. Show you care.